Okay, question 5 then is the normal distribution question. So we're told that we've got some still mineral water, and we've been given the actual volume x, maybe modelled by the normal distribution. So we're looking at something that is normal. The mean is 1,525 and the standard deviation 9.6. So for part A then, let's just write down that this variable x is modelled by a normal distribution with a mean of 1,525 and a standard deviation of 9.6. So we put the squared there because that means variance when we're talking about the normal distribution. So standard deviation squared gives us the variance. So for part A then, we are looking to determine whether the probability that the weight of a bottle is less than 1,540. So we start off by drawing our bell-shaped curve to just give us an idea of what we're working with. So we've got our mean here, and we've got our value that we've been given, 1,540, and we're looking for the probability that something is less than this. So we are looking for this section here. Now I'm going to show you first of all what we would then put onto our calculator, and then we'll just think about what we might want to write down also as additional workings to get all the marks. So we're going to our stats mode, distribution, and it is a normal distribution, and we're using the NCD, normal continuous distribution. So once we've clicked that, we can see that our lower limit in this case is going to be sort of a really big negative number. Okay, so that's our lower number, so somewhere all the way down here on our continuum. Our upper limit has to be a bit more precise, that is the 1,540. Let's just make sure I'm typing into the right thing. Our sigma is not going to change, it's 9.6, and our mean is 1,525. So our solution then is then given as that probability. So we're going to write that down as 0.9409 to 4 significant figures there. 4 significant figures. Now that's absolutely fine, and that will get me my 2 marks in the exam. If you look at the mark scheme, there is a method mark given for working out the Z value. Now, if you've got time at the end of the exam, it's certainly worth going back and doing this, or doing it while you're doing your normal question, because you're just ensuring that you do get your next mark. So we're looking for the probability that x is less than 1,540. And that can be found out by finding our Z value. So our Z value, and then this is where we use our formula x minus mu over sigma. And that's one we have to remember anyway, and we're going to use that later on in part B of this question. So if we just substitute those values in, so 1,540 minus 1,525 over 9.6, we can actually calculate that number quite quickly. That is the Z value that if you were to use your tables, you would then work out. So if we just use our standard calculator for this, it doesn't take more than a few seconds to actually do this once you're used to it. And this is the first method mark. So if you do make a slip on your calculator, knowing that Z is 1.5625, is ensuring that you are getting your first mark as well as your second mark. So this here is your kind of additional workings. This would be what you would have to do if you didn't have a graphical calculator and you were just using the tables from your formula book. So you'd be looking up that number to find the probability. But just putting that in as part of your workings, I'm not going to do it for each question, I'm just going to do it for this one and then move on quickly. But if you do this for each question, you're going to be sort of guaranteeing yourself you're not dropping marks for any slips on your calculator. So part two. We are using the same distribution, it's still a normal distribution, the mean is as it was and the standard deviation is the same. This time we are looking for the probability that x is bigger than 1,535 millilitres. So drawing myself a quick picture again, normal distribution, mean in the middle there, and 1,535 is to the right of the mean. So we are looking for this section here, and we're trying to find out that probability. So as I said earlier, you can do this in different ways, but we're just going to put all the information straight into our calculator. So we would go to distribution, and it's the normal distribution, normal continuous distribution. So in this case, the lower limit is 1,535. The upper limit is some big number over here, so we're going to go with 5 nines. The standard deviation is 9.6, and the mean is the mean given in the question, 1,525. So this probability here reads simply as 0.14878, and if you want to round that at all, you can do. So that was all we needed to do for our 2 marks there. If I just remove this, we'll have a look at part 3. Now this time we're looking for the probability that our variable x is between 2 values. So it's between 1,515 and 1,540. So again, just drawing myself a quick picture. I'll make my curve a little bit better there. The mean has still remained unchanged, and we've now got an upper limit and we've got a lower limit. So I'm looking for this area here. So changing only the upper and the lower limit is 1,515. And my upper limit is 1,540. And reading that off from my calculator is 0.79213. And again, you can round that if you wish to, but there's no real need to. And that again is then worth a couple of marks. As I said earlier, you can then go back and find your Z values to show that you've done your workings correctly. And if you have made some sort of slip, make sure that you haven't dropped all the marks there. Looking at part 4 then, this one is slightly different. What this question is testing is whether or not we know that the probability of a specific value, so the probability that x is equal to a number in the normal distribution is 0. Okay, it's not possible to get a specific value. Now, you may, if you've forgotten that, think, oh, well, I can just do distribution, normal, and do MPD, but unfortunately that does not give us the correct answer. We're not interested in our course in what this does do, we're not overly sure, but we don't want to use it. So instead we need to use this fact. So if the probability that a specific value equals 0, the probability that x does not equal a specific value is 1 minus 0, which is 1. And that was all we needed. Going back up here, looking at the question, this first bit was 2 marks, 2 marks, 2 marks, and this question is only worth 1 mark, so it's just testing whether or not you know that a specific value is not possible when using the normal distribution. Okay, for part B then, we are looking at a specific situation. So we want only 10% of the bottles to contain more than 1,535. The value of sigma is going to remain unchanged, so that is still going to be 9.6 from the original question, and we're asked to calculate the reduction of the value of mu. So how much is the mean that was 1,525 going to be reduced by? So if we just put our information we've been given in the question onto our bell-shaped curve. So the mean is the thing we don't know. We know that the 1,535 is going to have to be to the right of the mean, because this area here has got to be just 10%. Leaving the area to the left of the value to be 90%. So what we're going to do is we're going to set up our standardizing formula. Z equals the observed value minus the mean divided by sigma. Now the information that we have, we don't know the Z value yet, but we can calculate it. The X value is the 1,535. The mean is what we're trying to find out, and sigma is 9.6. So we want to find the Z value. Now we can use the tables and use the second table in our formula book to do with the mean, or we can use our calculator and just set it up to be the standardized normal distribution. So we're going to go distribution, normal, inverse normal. Now we can choose left or we can choose right. If I just leave it as left here, the left hand side of the value that I'm looking for, so the value is here, the left hand side, I want it to be 90%, so 0.9. In the standardized distribution, the sigma is equal to 1 and mu is equal to 0. So setting my calculator with these two values here mimics that second table in our formula book. So we don't even need to use the formula book here. Looking at that x value is actually our z value. So this tells me that z is equal to 1.28, let's go with 1.6 to 5 significant figures there. So that's how we can find our z value without having to use our formula tables. If you want to use your formula tables, that's absolutely fine, but you should get a value pretty much equal to that. So then we've just got a formula to rearrange. 1.2816 equals 1535 minus mu, all divided by 9.6. Okay, so let's just give us a bit more room here. We're just rearranging a formula now. So it's going to be 1.2816 times 9.6 equals 1535 equals, minus mu. So let's just work out what that one is there. 1.2816, multiply that by 9.6 and we get 12.30336. And that's equal to 1,535 minus mu. So from that value, subtract the 1,535 to tell me that minus mu equals minus 1,522.7. Equals the minus mu. So mu is the equal to that. Now a lot of students got this far, which was great, but this is only worth 3 of the 4 marks for this question. Because if we go back up to the question, it asks us to calculate the reduction in mu. So let's just highlight that bit. We're looking to calculate the reduction in the value of mu. So that means how much has mu had to be reduced by. So in order to work that out, we are going to have to subtract the value that we've just got from the original mu. So to finalise this question, just put the highlighter away, we are going to be doing the original value of mu, subtract the value we've just had, and that will give us the reduction. Now, it is just a kind of an additional extra that we don't normally see in these questions, but it does test whether we've read the question properly and whether we've understood exactly what we're being asked to do. So it's 2.3 there. The reduction is 2.3 millilitres. Okay, and that's the number that we're looking for in order to get the final 4th mark in this question. On to part C. Firstly, each of these two questions, each of these 2 parts are worth 3 marks. And before we start, the examiner's looking for an assumption to be written. Okay, stating a necessary assumption. Now, reading through what we've been told, sparkling water is supplied in packs of 6 bottles. The actual volume may be modeled by a normal distribution with a mean and a standard deviation. What do we have to assume? So we don't have to assume that it's normally distributed because we're told that in the question. What we have to assume, so the assumption that we must make, is that the 6 bottles represent a random sample. Okay, so the assumption is each pack contains a random sample. So instead of perhaps they're only packing the heaviest ones or they're only packing the lightest ones, that would mean that each of the packs of 6 bottles that were given were not a random sample. It just has to be a randomly selected bottle from the production line. So each pack contains a random sample. That's the necessary assumption. And in writing that, that's worth the 1st mark. And that assumption is kind of leading into part 1 and part 2 of this final part of part C of question 5. So we need to have made sure that we've written that assumption down because it's not stated in the question. Okay, moving on then, so just removing that now, so that was our 1st mark. The volume of each of the 6 bottles from a randomly selected pack is more than 505 millilitres. So in this one, what we're looking to do is to first of all find out the probability that the volume of one of the bottles is greater than 505. So we're looking in a different situation here. So we'll just draw our bell-shaped curve. This time the mean is 508.5 millilitres, and our key value, our observed value, is 505. So we're looking to find out the probability, first of all, that one of the bottles is greater than 505. So in order to do that, we're going to use our calculators again. This time, sorry, mine's just been from the previous part. We're going to go normal, NCD, and this time it's our lower limit is 505 and our upper limit is just a large number somewhere out of the way. Our sigma given in our question is 3.5, and our mu is the mean 508.5. So the probability that one bottle in each of these packs, so one of the 6 bottles being greater than 505, is 0.8413. Okay, so that's the probability that one bottle is greater than 505 millilitres. We wanted all 6. So it's one bottle and another and another and another and another and another. So we're going to be doing this number times itself 6 times. So if we then pop that to the power of 6, that's going to give us our solution to part 1 of this problem. So 0.8413 raised to the power of 6. And in doing that, we then get the probability 0.3546 to 4 significant figures, which is the final answer worth 3 marks. Getting to here is just worth 1 mark. Okay, you needed to have identified that we wanted 6 of them, so we raise it to the power of 6, and then once you've identified that, we can then say what the final answer is for our accuracy mark there. So that was part 1, C part 1 there, getting down to our answer. For C part 2, there is a word highlighted in bold, and a lot of my students who did this didn't spot this. The word highlighted in bold is the mean volume. So what we are looking for in this case, when we're doing the mean volume, it is the standard error. We're using our standard error formula. Now, that is because we are suddenly no longer looking at all of the bottles, we're looking at the mean. So the likelihood is that the standard deviation is going to be smaller because we're taking the mean of the 6 bottles. So the standard error formula is sigma over root m is equal to our new standard deviation. And that's all we needed to do for this question, is to change our standard deviation. So the original standard deviation, the population standard deviation, is 3.5. We have got 6 bottles in a sample. So our new standard deviation is going to be 3.5 divided by the square root of 6. So our new standard deviation is 1.4289. And then if we're looking through the question, it's a similar sort of question to before. So we are looking for the mean, does not change when we're using our standard error formula, because it's still going to be the mean when we take that, take the mean of a sample of 6. Our 505 is still in here, and we're still looking for the probability that's greater than 505. The thing that's changed is our standard deviation. So coming back into here, I've calculated what it is, just to guarantee myself the marks, because I want to make sure I've got my standard deviation written down somewhere. But actually on this graphical calculator, I can just type it straight in. So I want the square root of 6. Okay, and when you do that, it will just calculate it for us. And then there is our probability. So the probability that our new variable x is greater than 505 is really, really high. Okay, it's likely that the population, the sample of 6, the mean of that sample being greater than 505 is almost certain. Okay, so it's almost certain that when you take the mean of the 6 bottles in any sample, the mean the mean capacity, the millilitres will be higher than 505. So that's all 3 parts of question 5 there. Lots of marks available, but all just using our normal distribution in different ways.